Our last topic for today is about looking at the differences between linear, exponentials, and quadratics. I know that they look the same sometimes on tables or sometimes if you're given a list of numbers, but there's a pretty easy way to tell the difference between them, and it's really just looking at the rate of change for all of them. For linears, I hope you know by now that rate of change, in order to find the next number, you are either plussing or minusing to get to the next number. Okay, you're either adding or you're subtracting the same number every time to get to the next number. For exponentials, we know that we are either multiplying or we are dividing every time. We call this ratio of change. In other words, we were looking to see if we had to multiply by a certain number or to multiply by a fraction or in order to get the next number. Quadratic, we're kind of new at. We don't really know what's going on with that yet. If you look at the tables for all of them, linears, it's pretty clear for my first one to go from 5 to 8 to 11 to 14 to 17. I hope you know by now that this is plus 3. Because we are adding, keyword adding every time, and it's the same amount we're adding every time, that makes it a linear. We're doing plus 3, plus 3, plus 3, plus 3. You also notice that my x rate of change, 1, 2, 3, 4, that rate is also the same. Okay? For exponentials, if you take a look at the y values here, 2, 6, 18, 54, 162, if you think about the ratio of change, what we're multiplying or dividing by every time, this is a times 3. It's exponential because we are multiplying by it every time. Okay? The last one is a little bit tricky. I think you probably already know because it's under quadratic. It is a quadratic, of course. But in order to decide if it's quadratic, you actually have to look at the second difference. For my algebra class, we talked about this very briefly, so I'm going to go over it again. When you look at the second difference, you are looking at the difference of the differences. Whoa, this is what I mean. If I want to go from number to number, I check to see if the rate of change is the same if I add or subtract every time. It's not. I'm not adding the same number or subtracting the same number every time. I'm also not using the same ratio every time. I'm not multiplying by the same ratio to get to the next number. It's just not working. So instead, I got to try my third option. I'm going to look at the second difference. First, I have to calculate the first difference. To go from 4 to 7, I do plus 3. To go from 7 to 12, I do plus 5. To go from 12 to 19, I do plus 7. And then to go from 19 to 28, I do plus 9. Then I notice something. This difference that I found before, 3, 5, 7, 9, you might notice that we are adding 2 every time. Whoa, adding 2 every time. This second difference, it's the difference of the differences, this second difference is the same, and that is a classic quadratic trait. So when you have to decide between linear, exponential, or quadratic, you now have the tools to decide if you're adding or subtracting the same amount the first time every time, if you're multiplying or dividing by the same amount every time, or if your second difference is the same every time. I hope this is everything that you need to help you with deciding if something is linear, quadratic, or exponential. If you have any questions, please feel free to text me or email me. I'll be available all day. And tomorrow on Tuesday, I'm going to start my first office hour, so feel free to tune in to YouTube Live. I hope to see you there. Bye.